We continue to look at rational exponents, which means we raise a number or a variable to a fraction. That's what a rational number is, a fraction. So first, let's review these 5 formulas that we learned before. We know these exponents, these 5 rules work for positive exponents, positive integers, negative integers, and also they work for fractional exponents. So we can use these rules to do the problems with even fractional exponents. So let's look at the first example. So we multiply 2 times x to 1/4 times 6x raised to 2/5. Notice that we have fractional exponents. So like we said, that like the problems we did before. So if, for example, if I change those fractional exponents to integer, say we have 2 x third times 6 x squared. And remember, with the problem we did this kind of questions before. We switch 6 and x third, so we can multiply 2 and 6 to get a 12, and then we multiply x third times x squared. And by using the first formula, keep the base x and add the exponents 3 plus 2/5. So we're going to do exactly the same thing here. Even if we have fractional exponents, these formulas still work. So we can switch x to the 4th, raised to the 4th, and 6 to put 2 and 6 together. So we multiply them, we're going to get 12 times 6, 12 times 2, 6, 12. I'm sorry, 2 times 6, 12. And then we're going to multiply x to the 4th times x to 2/5. And notice that these two, they have exactly the same base x, xx, with different exponents, 1/4 and 2/5. And that fits exactly the first formula. We can keep the base x and add the exponents. Here we have 1/4 plus 2/5. Just like we add 3 and 2, we can also add fractions. So it doesn't matter if they are positive integers or negative integer. If we say we have -3 here, we can add a -3 and plus 2 to get a -1. But if we have fractions here, we just add these 2 fractions. And we continue. And next part, you can work on the scratch paper if you want. So we do have to work out what 1/4 plus 2/5 is. 1/4 plus 2/5 equal the denominator, which is 20. So let's multiply by 5, multiply by 4, and we get 5 plus 8, that's 13 over 20. So the exponent will be, after we add 1/4 and 2/5, we're going to get 13 over 20. And we can leave this as the answer. You don't have to change the rational exponent to a radical number. You can leave this as an answer. So that's how we use those rules to do the question. So you can see we're doing exactly the same steps we did before. The only thing new will be when we add exponents, we will be adding fractions. And we have to equal the denominator, find the LCD equal denominator, and do all that. Now let's look at the second example. We raise 2x 1/3, y to 1/2 to the 3rd. And by looking at the formula, we can see that number 3, the third formula will work on this, because in the base we have multiplication. And 2 times x to 1/3 and times y to 1/2. So although the formula only has 2 factors in the base, it also works if you have another one. Let's say if we have a z, and you can just put a z to the nth. So when we have multiplication in the base, doesn't matter how many we have, how many factors we're multiplying, we can distribute the exponent to each factor. So here in this case, we have 3 factors, 2, x to 1/3, and then y to 1/2. We can distribute the exponent to each of them. So we're going to raise 2 to 1/3 and raise x to 1/3 to 3rd. and then raise y 1/2 to the third. So we're going to get 2 to the third, and then x 1/3 to the third, and y to the 1/2 and to the third. So notice this third, I'm going to put it in red color, and that is the exponent on the outside. And everything in black will be the one in the base. So now we can work each one out. 2 to the third. Positive x integer means multiplying 3 copies. So 2 times 2 times 2, that gives us 8. X to 1/3 to the third. Now that's the second formula. When we raise the exponent to another exponent, we multiply the exponents. So we get x to the 1/3 times 3. 1/3 times 3. You can put a 3 over 1. So 1/3 times 3 over 1, that you can cancel then, which gives us 1. And similarly, we can work this out. It's multiplying 1/3 times 3. Again, I can put a 3 over 1. So over here, we need to know how to multiply exponents, how to multiply the fractions. So we have, when we cancel 3 and 3, we're just going to get a 1, because 1 times 1 over 1 times 1, which is 1 over 1, and 1 over 1 is also equal to 1. Now similarly, when we multiply 1/2 and 3 over 1, we get a multiply straight across. 1 times 3, 2 times 1, so we got 3/2. And so this is the answer. And that one here can be omitted if you want. If the exponent is 1, you can just omit it. So now let's see what formulas are used here. So first we use the formula number 3. If it's multiplication in the base, we can raise each of them to the exponent. And if we have exponent, if we raise an exponent to another exponent, we multiply these two exponents. The same here, so we can use the second formula. And so the formulas we're using are the same ones we used before, but the new thing is we may have to either add the fractions or multiply the fractions. Now the next example, we raise something to the third, but in the base we have a division. Something divided by something. 4x to raised to 2/3 divided by 5y raised to 1/4. As you can see that number 5, if in the base we have division, we can also raise each top and the bottom to that exponent. So we're going to get, let's work it out here. So we're going to raise the top 4 times x to 2/3 and raise to the exponent on the outside, the third. And then we're going to raise the bottom 5y to 1/4 raised to the third. So in example 2 and 3, you can see when we have either multiplication or division in the base, you can raise each of them, either each of factors or the numerator and denominator to the exponent on the outside. Now, let's work out the top. In the top, we have 4 times, so that, again, it's the third formula. So first, we use the formula 5 to raise the top to the exponent, raise the bottom to the exponent. But the next step, in the top, notice that there's another base, and that base has multiplication in there. So that's the third formula again. So we raise 4 to the third, and then we raise x to 2/3 and to the third. And similarly, we can raise in the denominator, we also have 5 times, that's multiplication in the base. So we raise 3 to the third, and we raise y to 1/4 to the third. Okay, next, so this step here, we use the third formula. In the final step, we just need to work out 4 to the third, which is 64. But when we multiply x, when we raise x to 2/3 to the third, again, that's the second formula here. When we raise a power to another power, we multiply the powers. So we're going to multiply these two powers. 2/3 times 3. I'm just going to write down the answer 2. because if you can't do that in your head, you can do it on your scratch paper. So put 2/3 times 3, put a 3 over 1, and when you cancel 3 and 3, you get squared. And for the bottom, we do the same thing. 5 cubed, it's 5 times 5 times 5. That gives us 125. Why to raise to 1/4 to the third? We again use the second formula. So this is formula 2 here. And for that part, we use the second formula 2. That is multiplying the exponents. That gives us 1/4 times 3. That's 3/4. If you cannot do it in your head, do it on the scratch paper. 1/3 times 3 over 1. Multiply straight across. 1 times 3 is 3. 4 times 1 is 4. So that would be the final answer. And notice x and y, they have different bases. We cannot use the fourth formula. To use the fourth formula, they must have the same base x or y. Since x and y are different, we cannot divide them any further. And 64 over 125, this is already reduced. They don't have any common factors. So this will be our final answer.